Hello, this is Professor Urbiswite. Today we are going to learn how to multiply radicals. So let's get started. First thing, when you have two radicals and you're multiplying them and they have the same index, that's good. So you can actually multiply the inside and put it together and multiply the outside. 2 times 3, that's 6. And you can do nth root of a squared. Okay. Now, when you multiply them with different indices, it's a whole different matter. So let's look at that. You multiply the things that are outside, that's 2 times 3, which is 6. And now you write this as an exponent notation, a to the 1/mth times a to the 1/nth. And this becomes that. And guess what? You have to put it in the same denominator. So move this up there, n. So n plus n divided by mn. What does that mean? You actually have the mn in here as an index, and then you have m plus n inside. So make sure you understand the difference between this and this one very, very well. Okay, you can pause this actually and look at it a little bit closely. So let's go do some of these. Okay, so let's go and do this, and I'm going to put it in the same big happy family. 3. What is 27? Remember, I can prime factor that. 3, 9, 3, 3. So that's actually 3 to the 3rd power. And what does that mean? This is actually square root of 3 to the 4th power, which is square root of 3 second and 3 second. This comes out, 3 times 3, 9. Okay? You don't have to put that many little steps in there, but that's how it works out. So I'm going to do the same things. I'm going to put it in big happy family and do the prime factorization and then kind of group them in groups of 4. So 8 is 2 to the 3rd power. And you have x to the 4th, you have y, z cubed, and you have another 2, you have x to the 2nd, you have y cubed, and z to the 7th. Alright, let's take some of them out that I can see already. 2 to the 3rd and a 2, there are 4 of them, that comes out. That comes out as 2. I have another x to the 4th, that comes out as x. Alright, you have a 1 here and a 3 here. Together, that's 4. That comes out as y. So this is left behind. And I have this situation. Let me rewrite this so you can see that. Z to the, so this is 4th root. Z to the 3 plus 7, that's 10. And you have x squared. For sure, the x squared is left behind, but some of this will come out. How is that? 2xy. Okay, so let's look at that. Groups of 4. So this is actually z4, z4, and z2. Remember, 4 is 8 plus 2, 10. So this comes out, this comes out. So what do you have? 2xy. And 2 z's came out, so that's z squared. What do you have left behind? 4th root of, you have an x squared here as well. So this guy is left behind, and this guy is left behind. X squared, z squared. Does it make sense? Very good. Now let's do something. We are doing a little bit more complex cases. When we multiply, let's say, a monomial, just like in case of polynomials, what do I get? You can just FOIL this just like you used to FOIL everything. So you are going to get radical 3 times x plus radical 3 times y. All right? Now, the thing is, when you write radicals, make sure that you put the radical sign, and then whatever you put inside, and put a little tick mark that kind of tells you where the radical sign ends, radical symbol ends. So let's do the same thing a little bit harder. So what is that? Radical 3, radical 5 minus radical 3 times 3. Can I put this two together? Yes. Radical 15. And usually it's customary to put the whole number without the radical first and then the radical. So you are going to have negative 3, radical 3. Does it make sense? Okay. Now, how about this one? It's getting more complex as we go along. So let's look at that. So what is this? I have this situation. First two, you're going to have y times y squared, so that's y cubed. 27, remember what that was? 3, 9, 3, 3. So that's actually 3 to the third power. All right, so when I multiply 3 to the third power with 3, I get 3 to the fourth power. Okay? And then minus. So let's do that one again. Radical. You have 3. The second one is going to be y squared. So can I take some of these out? When you take this out, that will come out as 3 squared. 2 of them will come out. That will come out as y. And you're going to have radical y left behind. Minus. This one stays in, and that comes out y radical 3. And this is as far as it goes, because these are not like terms. You cannot do anything about that. All right, now we're going to start foiling things. And let me do that. Okay, multiplying with a binomial. Remember the rules. A plus b, a minus b. What was that? First one squared minus last one squared. All right, what is the square of these two? If you want, we can write it one time. Rad x times rad x. First one squared. That will give you itself. Now, this one, second one. This one, this one. So that's minus rad y, that will give you y. All right, what happened to the middle terms? They actually canceled out. This one, xy minus xy. Do you see that? Those two will cancel out. So, shortcut. First one squared, which is square of that, x, minus last one squared, which is the square of that, y. Does it make sense? Okay. Now let's go one more step. How do I do a plus b, a minus b? I mean a plus b times a plus b. How does that work? You're going to FOIL it. These two, that's going to give you x. These two, that's going to, oops, I'm outside. That's going to give you plus xy. These two, we are going to give you plus yx. And these two, that's going to give you y. So what you get? This one is the same as a plus b squared. Remember, if you remember the formulas, that's going to be first one squared, last one squared, and what's the middle term? 2ab. Let's see if that turned out the same. First one squared, last one squared, and you have two of these guys. Actually, that does work. All right? So look what the first one ended up, a squared minus b squared. Look what this one ended up, x squared plus 2xy plus y. Okay, and then xy is in radical. All right? So the first one is going to be the square of this first term, square of the last term, and the twice first and last. How is this going to work out? Let's FOIL. That's going to be this times that, that's going to be x. This times that, that's going to be that one. This times that, that's going to be that one. And the last one, that's going to be that. So what is the difference? This is like a minus b squared. Remember what that was? It's a squared minus 2ab plus b squared. And did that turn out that way? It looks like it. X minus 2xy plus y. Do you see the difference? So the first one is just two terms. The middle term drops out. Second one, when it's plus plus, the middle term does not drop out, but you have a plus. And when it's minus, and the middle term does not drop out, and you're going to end up with a minus. It's kind of a pretty busy slide. Make sure you understand what you're doing. So let's see how I apply all this stuff. Okay. Now I'm going to FOIL it. And when it is all different things, this is just kind of a more complex case. And I just FOIL it. So let's look at the first term. How does the first term work out? Let me put another paper underneath so that it doesn't go through. All right, here we go. And then I'll put that in there. I think I'm all set now. The first one is 4 rad 3 rad 3. I'll write every step. The second one, minus 4 rad 3 rad 2. This one is plus rad 2 rad 3. Last one is negative rad 2 rad 2. Okay, let's look at that. What does this give you? 4 times 3. What does this give you? Negative 4 rad 6. What does that give you? Rad 6. And what is that? Negative 2. All right, this one is 12. Negative 4 plus 1, that's negative 3. Minus 2, which ends up being 12 minus 2, 10. Minus 3 rad 6. Okay, that's as pretty as it gets. And this was a complex case. Okay, the last example. How do I do this one? All right. Now, the index is not 2, so it's going to be a little bit different. So what do I have? The first one, cube root of a, cube root of a squared. The next one, negative 6, cube root of a. This one, plus 5, cube root of a squared. And this one is negative 30. Okay? So let's do that one. That one is cube root of a cube. This one is minus 6 cube root of a plus 5 cube root of a squared minus 30. Okay? Now let's see if I can do anything. This one is a, and this one is 30. How about all these guys? Can I combine these two? This one has a, this one has a square in it. Nuh-uh, I can't do it. So I just write it as is and leave them alone. Okay? So this is the end of this section.